Algebra 2 Cram, New York State, Algebra 2 Regents, Common Core, Logarithmic Function Basics. Concept number 1, Basic Graph of a Logarithmic Function. The odds of someone doing exactly what you tell them to do is pretty slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. So inbox me at memedicine@gmail.com to order and purchase the complete Algebra 2 cram session beyond the logarithmic function basics, okay? You have lots of friends, colleagues, classmates, and peers who could also benefit from this boost as well. So tell them to inbox me at memedicine@gmail.com to order the complete cram session. Logarithmic function. Describe the graph of a logarithmic function, or logarithmic function. You're probably better at pronouncing it than I am. Definitely press pause if you need time to think and construct a graph. All right, so hopefully by now you are able to arrive at an answer, and if not, that's fine. Let's attempt this together. In order to describe the graph of a logarithmic function, we first need to understand the general format of an exponential function, okay? The general format for an exponential function is y is equivalent to b raised to the x, where b is positive, it's not negative, and it's never going to be equivalent to 1, okay? So this is the general format for an exponential function, and we can see the graph here. It's never going to have an x value that's equivalent to 1, although it can approach 1, but it never actually touches. Okay? Alrighty then. So, yeah. What a lot of people do is they confuse polynomial functions and exponential functions. Well, a polynomial function actually has the reverse format where the base is the independent variable, or an x, and the exponent is a constant. So something like x squared, x to the third, those are polynomials. They're not exponentials, okay? So again, for an exponential function, the base is a constant. The exponent is the x value or independent variable, and the result is called a power. Often the terms power and exponent are exchanged, but power is actually a misnomer for exponent. The power is the result. Let's say the exponent were 2. The result would be, or y would be the second power of the base b, okay? So that's how we express that. And so now we get to a logarithmic function. And a logarithmic function is the inverse of the corresponding exponential function with the same base. So we have, for a logarithmic function, the result or dependent variable y is equivalent to the logarithm or log base b of x, okay? And you're probably wondering, like, what the heck? How do I, like, describe this in words? Well, let me clarify this for you a little bit. This means that since this function is the inverse of this function, it means that y equals log base b of x is going to be equivalent to x is equivalent to b raised to the y, because this is obviously the inverse function of this. And remember that algebraically, in order to yield the inverse function of your starting function, all you're going to do is switch the independent and dependent variables, which is what's done here, okay? Or you're simply going to switch x and y values. So for this particular inverse function, the constant is going to remain a constant, but x is now the power, or the result, and y is the exponent. All right, so the power or the result is now the x, and the exponent is y. Okay, so the way we can look at this is that y is the exponent you raise base b to in order to yield the power of x. Okay, except here your power is your input variable. All right, so let's see the graph of this bad boy. On a Cartesian coordinate plane, that's just a simple xy plane that we have depicted here. Or this is actually a log coordinate plane, which we'll get into in later sessions. On such a graph, the logarithmic function is the reflection of the graph of the corresponding exponential function through this line y equals x. And that's true of any function. If you want to yield the inverse function, you basically just flip it, okay, over the line y equals x. And that's when we get our graph of the log, okay? Alrighty then. So this is what the graph looks like. It's just a flip of the exponential function y equals b to the x over the line y equals x. And as you can see, intellectual comprehension of this material wasn't difficult at all. The graph may be a little off and not drawn to scale because here you're not supposed to have a value of 1. This is supposed to depict approaching 1 but never actually touching it. Yeah, something like that. And after the short amount of time it takes to complete this entire Cram session, you'll be able to answer a battery of questions about any Algebra 2 concept. So inbox me at memedicine@gmail.com to order and purchase the complete Cram session. Thanks for tuning in and good luck studying.